Just three more people joining. So, okay, so we start the lesson analytical chemistry. I think the other teacher took metallurgy and hydrogen chloride. Am I right? Any one of you could answer me?
Yes, sir.
Okay, so today we will see analytical chemistry. So this is very interesting and very easy to learn and remember. So learning is not simply attending the class. You should remember what you have learned at the end of the class. Understand? So that is how we should approach each and every lesson in chemistry at least. Okay, I hope all of you are aware. I have been telling very often, no, you should know the symbols and valencies very thoroughly. Am I right? If you know the symbols and valencies of all the ions, this chapter is going to take hardly 15 minutes for us. Okay, so we'll see one by one now. This is chapter 4 in your textbook. So, what is meant by analytical chemistry? See, analytical chemistry means suppose you are given a chemical substance, you should be able to find out what all the components present in it in the very first place. So, what is a positive ion present in it? What is a negative ion present in it? And how to identify them. That is what is known as analytical chemistry. So, once you find out what all the components present in it, for example, suppose you are given a salt, you should be able to find out what that salt is, whether it is a copper sulfate salt or aluminum nitrate salt. So there are so many different salts, isn't it? Each salt is a compound that will contain one positive ion and a negative ion. So how to find out that? That is what is known as analytical chemistry. And second part of the analytical chemistry is how much each component is present. For example, somebody is waiting. Let me admit them. So for example, if you are given a salt, can you see me writing on the screen? Can you see it?
Yes, sir.
Okay. Suppose you are given a salt copper sulfate. You identified it as copper and sulfate. Copper is the positive ion and sulfate is the negative ion. After identifying it, we should be able to find out the percentage composition. How much copper is there? How much sulfur is there? How much oxygen is there? See, already we have learned that in previous chapter how to find out the empirical formula, how to find out the molecular formula, all those things. So that is the second part of the analytical chemistry. Suppose you find out what all the components present in it, like copper, sulfur, and oxygen are present. So this is known as qualitative analysis. Quality, what quality is present? What are the components of the chemical substance? This is known as qualitative analysis. And how much is present? So what is present is qualitative analysis, and how much is present? What is the percentage composition? That is known as quantitative analysis. Quantitative analysis. So let's see one by one very quickly now. So what is meant by analysis? So identifying the components of the unknown substance. Identify identifying the unknown components. That is what, see, or else we can see, or we can say determination of chemical components. See, for example, you are given a salt here. So suppose let us take this is a salt. Just now I explained to you what all the chemical components present in it. For example, if it is a copper sulfate, you will find out copper is present, sulfur is present, and oxygen is present. So this is known as qualitative analysis. And how much copper, how much sulfur, how much oxygen is present in it is known as quantitative analysis. That is what. What is qualitative analysis? Identifying the components present in it. present in a chemical substance is known as qualitative analysis. Then what is meant by quantitative analysis? How much of each component is present, that is known as the composition. The composition of various chemical components is known as quantitative analysis. Is it clear? So they may ask you question, what is meant by analysis? Determination of chemical components in a chemical substance is known as analysis. What is meant by qualitative analysis? What are the chemical components present in a given chemical substance is known as qualitative analysis. Next one, what is meant by quantitative analysis? How much percentage of each and every component is present in the given chemical substance. So identifying that is known as quantitative analysis. Hope it is very clear to you. And then what is meant by reagent? What is meant by reagent? Can anyone tell me what is meant by reagent? Madesh, can you answer me what is reagent? Hello, are you there? Or Nalme, can you answer me what is a reagent?
It's an apparatus, sir.
Apparatus. Reagent. No, reagent is a chemical substance. That's not.
Can you please let them in, sir?
It is a chemical substance which can react with any other chemical substance is known as reagent. Understand? So reagent is a chemical substance which can react with another chemical substance. That's it. See, for example, if you take sodium chloride, it's a salt, okay, and you are taking hydrochloric acid. If you add hydrochloric acid solution to sodium chloride salt, this will react. Therefore, hydrochloric acid is a reagent. Hydrochloric acid is a reagent. Is it clear? Clear or not? So what is a reagent? Reagent is a chemical substance that react with another chemical substance is known as a chemical substance which reacts with any other chemical substance is known as a reagent. Okay. So what for we are using reagent? So many reagents are used to identify the chemical components present in the given chemical substance. For example, sodium hydroxide, hydrochloric acid, ammonium hydroxide, all these things are example for reagents. So these are all used to identify what chemical component is present in the given chemical substance. So these are all known as, these are all example for chemical reagent or simply reagent. Therefore, if they ask you a question, what is meant by reagent, what answer you will write? A chemical substance which reacts with any other chemical substance in order to identify the chemical components is known as reagent. Example for reagents are sodium hydroxide, hydrochloric acid, ammonium hydroxide, everything. And in this chapter, what we have got in 10th standard is we are going to learn about the two reagents, sodium hydroxide and ammonium chloride. So using these two reagents, how we can identify various components present in the given chemical substance. So this is what is all about this analytical chemistry in 10th standard syllabus. Clear? Sodium hydroxide is a reagent, not ammonium chloride. This is also ammonium hydroxide. I'm sorry. So sodium hydroxide and ammonium hydroxide are the two reagents about which we are going to learn in this analytical chemistry chapter in 10th standard. So using these two chemical reagents, how we can identify various components in the given chemical substance. And that is what we are going to learn about in this chapter. Hope it is very clear what this chapter is all about. What is meant by analytical chemistry? See, analysis means suppose you are given a chemical substance, new chemical substance, unknown chemical substance. First of all, you need to find out what all the chemical components present in it. That is known as qualitative analysis. And how much each component is present, that means you will find out the percentage and then empirical formula and molecular formula. That is known as quantitative analysis. Is it clear? What is meant by qualitative analysis and what is meant by quantitative analysis? Okay, in order to find out, in order to analyze what are the chemical components present, we have to use reagents. So we are going to use two reagents. One is sodium hydroxide, the other one is ammonium hydroxide. Using these two reagents, how we can identify various components in the chemical substance. That is what is all about this chapter. Hope it is very clear. Can I take it for granted you have understood this, what we are going to see in this chapter? Can anyone answer me yes or no? Or,
Yes, sir.
or you can ask me any
Excuse
question.
me, sir. So some
Any,
of them are waiting. Can you please let them in, sir?
yeah, sure, definitely. Okay, I think all of you have come and I have admitted all of you. Kritat, you should be on time. Understand? Kritat, are you there? Hello? Okay,
We can hear, sir.
yeah, you should be on time. You should not be late. I should be the last person entering into the class. Understand? All of you should be readily. You should be ready.
Sir, we were there, sir. In the waiting room, we were there.
But I could see you only now in the waiting room, not when I came or when
No,
I.
sir. From long time we were there. That only we were discussing on the WhatsApp also. It's taking so long.
Okay, fine. Okay, I'm sorry if I have not seen you, but I didn't see many of you when I came here. Okay, so you should be present on time. Okay, sir, that's fine. So now we can go ahead. So for the latecomers, I just repeat one more time. So what is meant by analysis? Analysis means suppose you are given a chemical substance, unknown chemical substance. First of all, you should find out what all the chemical components present in it. That is what is known as qualitative analysis. And how much percentage of each component is present is known as quantitative analysis. Okay, so we are not going to deal with quantitative analysis in this chapter. So we are going to see only qualitative analysis. What are the chemical components present in it? In order to find out the chemical components present in a given chemical substance, we need to use reagents. Reagents means what? A chemical substance which can react with another chemical substance and they will change its color. So by the change of color, we can identify what chemical component is present in it. So a chemical substance which can react with another chemical substance is known as reagent. So there are so many reagents, but we are going to you take only two reagents in our syllabus. One is sodium hydroxide, the other one is ammonium hydroxide. How we can use these two reagents in order to find out what are the chemical components present in the given unknown chemical substance. So just imagine you are given a salt and you are asked to find out, okay, what that salt is. How will you proceed? Now we should know certain procedures, know how they react with sodium hydroxide and what color you will get. And similarly, how they react with ammonium hydroxide and what different color you will get when they react with ammonium hydroxide. If we know all these things, we can easily identify what are the chemical components present in the given chemical substance. Okay, very simple. It is going to be easy. Just keep listening to me. So can you see the screen, all of you? Hello?
No,
No, sir.
sir.
No,
No,
sir.
sir.
Okay, just
No,
a,
sir.
just a minute. Hope you are able to see now.
Yes, sir.
Yes, sir.
Okay.
Okay, good. So these are the 6 ions we have to study in detail in our syllabus. Suppose these are the 6 positive ions in the given chemical components. Copper. This is copper 2. I'm sorry. So this is copper 2. What is the color of copper 2? Can anyone tell me? What is this color? The copper is having two valencies, no? Copper 1 and copper 2. We have got two different valencies. So what is the color of copper 2? Can anyone tell me?
Blue.
Blue. Excellent. Very good. Okay. What is the color of iron 2 plus?
Light green.
Light green or pale green? Okay, or dirty green? Okay, whatever it is. The green should come there. Okay, very good. Then what is the color of iron 3?
Yellowish brown.
Yellowish brown or reddish brown. Okay, but in your textbook it is given yellowish brown. So from the way you are selling yellowish brown, I can easily guess you are seeing your textbook. Am I right?
Yes, sir.
Okay. You need not have your textbook. You can just pay attention to me. Okay, nickel. What is the color of nickel and chromium? Both are green. Both are green. Okay. So iron 2, nickel and chromium all are green. And what is the color of manganese? Manganese is pink. Okay, like this, there are so many positive ions. They all can form different colors. But at least for these 6, which are in our syllabus, only these 6 ions are in our syllabus. We should know the color of these salts forever. We should not forget it. Okay, I give you 15 seconds time. So what are the 6 ions in our syllabus and what is its color, you should know. Don't think that you can go back and sit and learn afterwards. Okay, you shouldn't do that. So learn it right now here itself. Meanwhile, I admit somebody is waiting already. So copper, blue color, iron 2, copper 2 is blue, iron 2 is pale green, iron 3 is yellowish brown, and nickel is green, chromium is also green, and manganese is pink. You can always remember, Fenicer is green, Fenicer, Fe3 plus no, then nickel, and then chromium. These 3 are green in color. All the 3 are green in color. And copper is blue, iron 2 is green, not iron 3, iron 2. Iron 3 is yellowish brown as per textbook color. But you see the next page in the textbook that would have given, they would have given it as reddish brown. Okay, so what to take, yellowish brown or reddish brown? Actually, it is reddish brown. I don't know why they are given as yellowish brown. Reddish brown is the correct answer. So in the next page, in the same lesson in your textbook, you will find iron 3 is reddish brown. Okay. So always answer reddish brown. Okay, I hope you understood these 6 ions now and you have memorized these 6 ions and what are their colors. Don't forget it. So try to remember it. Don't think that you can learn it later. If you listen to me, here itself you can learn everything. Okay. Okay, now. What are some of the negative ions are also colored, but we are not having in our syllabus. We are going to find out only positive ions in our syllabus. How to identify the negative ions is not there in our syllabus, but at least we should know the colors of some of the negative ions. Can anyone tell me what is the name of this one? Mn O4 minus 1. Can anyone tell me what is its name? How many times I told you should learn and remember the symbols, names, and valencies. So this is known as permanganate. This is known as permanganate. What is the color of permanganate? Pink or purple? Pink or purple. So MnO4, this is having 2 different valencies. Negative ion valency 1, negative ion valency 2. When the valency is 1, it is known as permanganate. It's what you cannot afford to forget all these things. These are all something like your own names now. And when the valency is 2, its name is manganate. Its name is manganate. And the valency is 2, it is called manganate. When the valency is minus 1, that is permanganate. So it is not minus 1, the valency is 1 only. Since it is a negative ion, we are calling it as minus 1. So MnO4 minus 1 is pink color or purple color. And the next ion is Cr2O7, that is dichromate. So this is dichromate. So the color of dichromate is orange. Orange. See how I remembered when I was a kid like you, or when I was learning first time chemistry. See, if the color is orange, no. So immediately I visualize an orange fruit. Okay, let us take this is an orange fruit. And two crows were sitting and eating this. Dichromate. Okay. So two crows. So these are the two crows. Okay. So they were eating that orange, dichromate. So eight, no? So eight, eat. Okay, so we can get it. So dicrows are eating that orange. So I got it dichromate. So that is orange in color. So to remember that is orange in color, I have taken the fruit orange. So all these things know that elaboration of the information is very important to remember. Okay. Then the other one is chromate. So a crow is sitting on a mat. So let us consider this is a mat. So let us consider this is a mat. A crow is sitting on the mat. Chromate. So the color is yellow. I'm sorry. So the color is yellow. So this is chromate. So its color is yellow. So you can imagine the crow is yellow in color, not black in color. And the mat is also yellow in color. So just by visualizing that, anytime if somebody asks you what is the color of chromate, immediately you can visualize a crow in yellow color, isn't it? Am I right? Can anyone tell me?
Yes, sir.
You agree?
Yes, sir.
So all these things becomes very
Yes,
easy to
sir.
remember. Okay, okay. All these things becomes very easy to remember. You should not go on reading in chromate is yellow color, thinking of the movie released for the Diwali. Understand? You can think of that thing, no, exactly what you are learning. Chromate. So split and make it a picture. Chromate. A crow is sitting on a mat, which is yellow in color. Then dicrows. No, two crows are eating orange fruit. So that is orange in color. Dichromate. Then permanganate, permanent magnet, a magnet which is permanent. Okay, so permanent magnet is permanganate. So what is the color of that magnet? That is pink in color. You convert it into some concrete image and try to visualize the color, and you will not forget. So simply they will ask in one more question, what is the color of dichromate? If you know the answer, you will get 1 mark. If you don't know the answer, you will get 0 mark. So here only the memory is tested. Understand? Okay, you can expect such questions here and there. Because in chemistry, they are not going to ask you one full 10-mark question. So they will ask you 5 questions for 5 marks. Some questions may carry 2 marks, some questions carry half a mark, some questions may carry 1 mark. Therefore, these small details are very, very important. You cannot go on forgetting and relearning it. Understand? Okay, I hope now permanganate, immediately you can think of a permanent magnet which is pink in color. Dichromate, you can think of an orange, and two crows are eating. Okay, dichromate. Okay, dichromate. Okay, then chromate. The crow is sitting on a mat which is yellow in color. Okay, that is more than enough. Okay, if I ask you some question based on the positive ion and negative ion, can you tell me the answer? What is the color of chromium? Chromium 3 ion. What is the color of chromium?
Green.
Green. Very good.
Green.
What is the color of dichromate?
Orange.
Orange.
You are able to get the picture instantly, isn't it? Whatever the thing I explained you should be able to get the picture, and from the picture you should be able to tell me the color. Okay, good. So you practice after the class. Okay, now alkalis are important lab reagents. What is meant by alkali? I think I told you already. The base which are soluble in water, am I right? The bases which are soluble in water are called alkalis. For example, what is meant by a base? Anything which contains OH minus ion. That is this hydroxyl ion. Any chemical substance is having OH minus ion is called base. And if it is soluble in water, if it is soluble in water, that is known as alkali. That is known as alkali. If it is not soluble in water, then that is not an alkali, but still that is a base. For example, you take zinc hydroxide. Zinc hydroxide is a base because it is having OH minus ion. Okay, but it is not an alkali. It is not alkali. Why? Because this is insoluble in water. So those bases which are soluble in water are called alkalis. So we are going to deal with alkalis. One is sodium hydroxide, the other one is potassium hydroxide. So these two things are not only bases, but are also alkalis because both are soluble in water. If you take aluminum hydroxide, again it is a base, but it is not an alkali because these two hydroxides are bases but not soluble in water. Therefore, they are not alkalis. Therefore, what you can say, what is meant by base? Those chemical substances which contain OH minus ion are called bases. And what is meant by alkali? Those bases which are soluble in water are called alkalis. Understand? Those bases which are soluble in water are called alkalis. Example, sodium hydroxide and potassium hydroxide. Zinc hydroxide and aluminum hydroxides are bases, but not alkalis because they are insoluble in water. Okay. Now, alkalis are important lab reagents. Sodium hydroxide, potassium hydroxide, ammonium hydroxide. So these are all examples of lab reagents in order to identify those 6 ions, 6 positive ions we had seen in previous slides. Okay, these are the 6 positive ions we had seen. So we can use sodium hydroxide, potassium hydroxide, and ammonium hydroxide in order to identify whether these ions are present in the given chemical substance or not. Okay, how we can find out that? We are going to see them one by one. Okay, so this is what we are going to see now. So you take any salt solution, and you add alkali. For example, alkali means sodium hydroxide. You will get a particular color. Already you have learned the color of each and every positive ion. And what positive ion is present, based on that you will get a particular color. That's what we are going to see now. Okay, very simple. Okay, suppose you are given a salt. So in a watch class, you are given a salt. Okay, this is a salt. And you need to find out what salt it is. Okay, what is the positive ion present in it? What do you have to do? So you have to take a pinch of the salt here. Okay, you are taking a pinch of the salt here. Okay, pinch of the salt. And then you have to add sodium hydroxide. Then you add sodium hydroxide. So what will happen? What is the positive ion present in the salt? Accordingly, that will react with sodium hydroxide and form some product that will be forming a different color, specific characteristic color based on the positive ion present in it. So here, what is the ion present? Calcium, right? Calcium is present. Therefore, what are the products formed? So you have dissolved the salt solution. So you dissolve the salt in water, and then you are adding sodium hydroxide here. What will happen? The salt solution will react with sodium hydroxide. Suppose the salt is calcium nitrate. The salt is calcium nitrate, and you are adding sodium hydroxide. So what is the product you will get? You can guess easily now. Calcium nitrate is a compound. Sodium hydroxide is also a compound. Therefore, this will undergo double displacement reaction. Therefore, what will you get? Calcium hydroxide will be one product, and sodium nitrate will be the other product. Am I right? You understand this or not?
Yes, sir.
Yes, sir.
So
Yes, sir.
what are the two products?
Yes, sir.
Okay, good. So what are the two products you get? Calcium hydroxide plus sodium nitrate.
Sodium nitrate.
Sodium nitrate. Okay. So sodium nitrate is colorless. Sodium nitrate is colorless. So it is soluble in water. Therefore, that will appear a solution here. But calcium hydroxide is a precipitate. Calcium hydroxide is a precipitate. So therefore, this will be a solid substance. And the color of calcium hydroxide is white. The color of calcium hydroxide is white. Is it clear? See, suppose you are adding sodium hydroxide to the given salt solution. If you are getting a white precipitate, that will be calcium. The positive ion present in the chemical substance will be calcium. Have you understood this now?
Yes, sir.
Why that white precipitate is formed? Because calcium hydroxide color is white. How that calcium hydroxide is formed? Because that salt contains calcium positive ion. If calcium is not present, calcium hydroxide would not have formed. Am I right? If calcium hydroxide is not formed, white precipitate would not have formed. Am I right? From the white precipitate, what we understand? We understand the positive ion present in the salt is calcium. Is it clear? So here, sodium,
Yes, sir.
here sodium hydroxide is used as a lab reagent. It is used as the lab reagent. So we are taking the given calcium nitrate salt in a test tube and you are dissolving it in water. That is what is known as salt solution. To which what we are adding? We are adding sodium hydroxide solution. Since calcium is present, so it undergoes double displacement reaction and calcium hydroxide precipitate is formed. What is the color of calcium hydroxide precipitate? White. So from the white color, we understand calcium hydroxide might have formed because the salt contains calcium. Therefore, the positive ion present in the salt is calcium. We can easily identify that. But just to explain this, they cannot give you full marks. What you are supposed to do? You need to write the equations correctly, isn't it? Everything is equation. If you take your textbook and see, everything is explained in equation. That is what is very important now. Okay, how to write the formula now? Calcium nitrate. I have already taught you several times. Calcium symbol is Ca. Nitrate formula is NO3.
NO3.
Calcium valency is 2, nitrate valency is 1. Therefore, if you interchange, you will get CaNO3 twice. Okay. Then sodium hydroxide, already we know the formula. So what is how can you derive sodium hydroxide? Sodium is Na, hydroxide is OH. Both valency 1. Therefore, if you interchange, you will get NaOH. Okay. Therefore, the reactant side, what will be the formula?
CaNO3 twice
plus
plus
NaOH.
NaOH.
Okay, good. Now, what is the formula of calcium hydroxide? Calcium is Ca, hydroxide is OH. The valency of calcium is 2. The valency of hydroxide is 1. I think all of you could see what I'm writing, no?
Yes, sir.
Yes, sir.
Okay, now if you interchange, what do you get? CaOH twice. CaOH twice. Therefore, one of the products will be CaOH twice. So this is what is white precipitate. So the white precipitate will form only if the given salt contains calcium, am I right? If there is no calcium, the white precipitate will not form. And from the formation of white precipitate, we can guess, we can identify, we can say this salt contains calcium positive ion. So what is the other product? Sodium nitrate. What is the formula of sodium nitrate? NaNO3. Sodium valency is 1, nitrate valency is 1. Therefore, you get NaNO3. Okay, so this is what is the final chemical equation we need to write. Clear?
Yes, sir.
And of course, we need to balance the equation. We need to balance the equation. So we have seen elaborately now how to balance a chemical equation. I don't want to waste your time and my time here, but I will teach you how to balance the equation after teaching everything. Okay, because balancing the equation you should know by now. Shall we move on to the next one? See, all the 6 ions we need to find out. First thing, we have found out calcium now. Calcium is white color, no? Calcium hydroxide. The next one, you should be able to tell me now. Ferrous sulfate, sodium hydroxide. So you are given ferrous sulfate salt, but you don't know what it is. So take the salt here. Salt solution. Salt solution means what? Dissolve it in water. Okay. You dissolve the salt solution in water. And what do you need to add? You are adding sodium hydroxide solution. You are adding sodium hydroxide solution. Okay. What is the product you expect here? Can anyone tell me?
Sodium sulfate and ferrous hydroxide.
Yeah, very good. So how do you say this product? Okay, your answer is perfect, but I want the reason how you got that answer. You should be able to tell me, no, ferrous sulfate is a compound. Sodium hydroxide is also a compound. Therefore, when a compound reacts with another compound, double displacement reaction will take place. What is meant by double displacement reaction? Positive of the first compound will react with negative of the second
compound.
And positive of the second compound will react with negative of the first compound.
Negative of first compound.
Okay, therefore, what will be the answer? Ferrous hydroxide. Ferrous hydroxide. Plus sodium sulfate. Ferrous hydroxide plus sodium sulfate. Okay, so what is the color of ferrous? Green, am I right?
Yes.
Green.
Pale green.
Pale green.
Okay, so you will get Pale green precipitate. Pale green precipitate. Understand? See, sulfate, ferrous sulfate salts are soluble in water, but hydroxide salts are insoluble in water. Okay, these hydroxides, only sodium hydroxide and potassium hydroxides are soluble in water. That is why we are getting a precipitate. That is why we are getting a precipitate. Understand? Ferrous sulfate will be a solution. If you add water to ferrous sulfate salt will dissolve. But if you add water to ferrous hydroxide, it won't dissolve. Understand? That is why sodium hydroxide is used for identifying these ions. Understand? And this is soluble. Sodium sulfate is a solution. Therefore, you will get a green color, pale green color. So from the pale green color, what we can say? We can say this salt contains ferrous ion in it. Understand? Now, how will you write the formula? What is the formula of ferrous sulfate? FeSO4.
SO4.
Ferrous means valency 2.
2 plus.
Ferric means valency 3. Okay, somebody is saying 2 plus. Correct. Very good. So ferrous 2 and sulfate is also 2. If you simplify, you get 1:1. If you interchange, you get FeSO4. Okay, that's fine. Then what is sodium hydroxide? Already we learned no the previous one. 1:1. Interchange, you'll get NaOH. Okay, that's fine. And then what is ferrous hydroxide? So just now we said Fe ferrous valency is 2. Hydroxide OH valency is 1. Therefore, if you interchange, you get FeOH twice. So this is a precipitate. Precipitate means what? That will not dissolve in water. That will appear as solid substance. Okay, precipitate. And what is the color? Pale green. All right. From this we understand the positive ion present in the salt is ferrous. Okay, plus what you get? Sodium sulfate. What is the formula? Sodium Na, sulfate is SO4. Sodium valency 1, sulfate valency 2. Therefore, you get Na2SO4. You got it?
Yes, sir.
Okay, see, you can ask me one question. Sir, ferrous is green in color. Either it is ferrous sulfate or ferrous hydroxide. Both will be green in color only. Then how can we distinguish whether it is ferrous sulfate or ferrous hydroxide? That is what I told you already. Remember this point very clearly. Only hydroxide salts are insoluble. Understand? Ferrous hydroxide is insoluble. They appear as solid substance, precipitate. But ferrous sulfate is soluble in water. The solution will be in green, but you won't get a precipitate. But ferrous hydroxide will appear as a precipitate, thick solid substance. Understand? You got my point?
Yes, sir.
Okay. Shall we move on to the next one?
Yes, sir. Yes, sir.
Now, can anyone tell me? Suppose you are given a salt which is ferric chloride. You want to find out whether ferric is present in it. What do you need to do? So in a test tube, you take the salt and dissolve it in water. So you will take the salt solution. And what you need to add? You need to add sodium hydroxide. Okay, can anyone tell me what is the answer you get? Sanjay, can you tell me the answer? Nobody.
So ferric hydroxide plus sodium chloride.
Can you explain me why?
Ferric is a compound and hydroxide is a
Ferric chloride is a compound. Sodium hydroxide is also a compound. That is what? No, you have to guess. Your answer is correct, but you should tell me the reason. You should be able to reason out. Only then you are thinking.
Okay, sir.
the positive
Sir,
compound.
it has ions.
Okay, tell
So
me.
the positive reacts with the negative ion. So that is the ferric is a positive and hydroxide is a negative. So this ferric and hydroxide combines and forms ferric hydroxide
Plus
plus sodium chloride.
sodium chloride. Okay. Now, what is the color of ferric? Already you learned what is the color of ferric.
Reddish brown.
Reddish.
Reddish brown. Okay, in the equation it is given reddish brown, but in the front page it is given yellowish brown. Am I right? In the textbook, two different versions are given, but in the equation it is given reddish brown. That is how I learned some 40-50 years ago. Reddish brown. Suddenly I don't know how it is given as yellowish brown. I don't know. Okay, so you stick to reddish brown. Okay, now can you write the equation? Can anyone tell me what is the formula of ferric chloride?
Fe3
FeCl3.
FeCl. So valency of ferric is 3, chloride is 1. If you interchange, you will get FeCl3. Okay, then what is the formula of sodium hydroxide? Already we know. So NaOH.
Na.
Okay, now what is the formula of ferric hydroxide? Fe valency 3, hydroxide valency 1. So if you interchange, what do you get?
FeOH thrice.
FeOH thrice. What is its color? Reddish brown. Am I right?
Yes, sir.
Reddish brown. This is a precipitate. Understand? Whereas here it is a solution. Ferric chloride is soluble in water. Only ferric hydroxide is insoluble in water. This will form as a thick solid precipitate. And that will be reddish brown in color. And what is the last one? Sodium chloride. You know sodium is Na, chloride is Cl, valency 1 and 1. Therefore, you get NaCl. You got it? See, that is what I have been telling now right from chapter 1. If you know symbols and valencies, if you know how to recognize the product, nothing to memorize in chemistry. On the spot, we can do everything. Okay, so shall we move on to the next one? Hope it is very clear to you.
Yes, sir.
Okay, so no doubt, no.
Sir, can you show an example of single displacement reaction?
Okay, so first we'll finish up this, then we can go to single.
Okay, sir.
Okay, so let us not break what we are saying. It we see all the 6 equations, and then I can answer it. Okay.
Yes, sir.
So now again, copper 2 sulfate. See, copper 2 means what? Cupric, no? So valency of copper is 2. So that means cupric. So cupric sulfate plus sodium hydroxide. Can you guess me the product? Can any one of you tell me the product? Hello?
Copper
Copper
hydroxide
hydroxide
plus
and
sodium
sodium
sulfate.
sulfate.
Either you have to say copper 2 hydroxide or cupric hydroxide. If you say copper hydroxide, how can I take it whether it is valency 1 or 2? Copper is having
Copper 2
valency,
hydroxide.
but 2 hydroxide. Otherwise, if you write copper hydroxide, your answer is wrong. Understand? Copper 2 hydroxide. Or you have to mention cupric. If copper valency is 1, that is known as cuprous. These basics you should remember. No? Right from 6th standard we are learning. Okay. So what are the products we expect? Cupric, hydroxide, plus what is the other product?
Sodium sulfate.
Sodium sulfate. Okay. Now can you guess the color of the cupric hydroxide? What is the color of cupric hydroxide?
Blue.
Blue. So copper 2 is blue, no? Therefore you'll get blue. Here you will get a blue precipitate. You will get a blue precipitate. Understand? From the blue precipitate, solid substance obtained. One of the product is precipitate solid. The sodium sulfate is liquid. Sodium sulfate will be liquid. Therefore, we can easily find out the blue precipitate indicates copper 2 ion is present in the given salt. Is it clear? So how can you write the formula? So copper 2, so valency 2, sulfate also 2. You simplify 1:1. Therefore, CuSO4. Then what is sodium hydroxide? Already we know, NaOH. Then cupric hydroxide, cupric valency 2, hydroxide valency 1. So if you interchange, you get CuOH twice. Plus sodium sulfate. Sodium Na, sulfate is SO4. Sodium valency 1, sulfate valency 2. Therefore, we get Na2SO4. So this cupric hydroxide is blue precipitate. Blue precipitate. From this blue precipitate, we understand that copper 2 ion is present in the given salt. Is it clear?
Yes, sir.
Clear or not?
Yes, sir.
Okay. So that is what I know. Your difficulty is not knowing the symbols and valencies. Right from day one, I am telling, okay, you have to invest your time to learn the symbol and valencies thoroughly. And some of you, at least I could sense from your voice, some 10 to 15 children, you are able to answer perfectly. So that's a good sign. The rest of the children, those who have not mastered the symbols and valencies, please invest your time. Okay, sit down and learn all these symbols and valencies. Writing the chemical equations are very simple. So hereafter, all the 5 remaining chapters are full of equations like this one. Only thing is you need to remember symbols and valencies so that you can write the answer on your own. Okay, next one, zinc sulfate plus sodium hydroxide. So you are given zinc sulfate salt, but you do not know that is zinc sulfate. So you take the salt and dissolve it in water, you will get the salt solution. That salt will dissolve in water. Okay, salt solution. Okay. And what you need to add? You need to add sodium hydroxide. You need to add sodium hydroxide. So what is the precipitate you will get? Zinc hydroxide precipitate you will get. Am I right? Yes or no?
Yes, sir.
Zinc hydroxide, this is one of the products. The other product is sodium sulfate. Because it is a double displacement reaction. Zinc hydroxide plus sodium sulfate. See, I could have written all the formula already on the screen and I could have told you. I am writing here. Why I am writing in front of you? So that you can follow me and at least by now you can try to understand how we can derive the formula on our own. Understand? Okay, zinc sulfate. So what is the formula of zinc sulfate? Zn SO4. Zinc valency is 2, sulfate valency is also 2. You simplify, you get Zn SO4. See, I learned all these symbols and valencies in 1970s. Even after 50 years, I am still using the basics when I am writing. I never write fully right from my rote memory. I always use the basic concept, symbols and valencies. I derive always. That is why it is sticking well. Stick to it. Stick to those basics. Okay. Na. Okay. Sodium hydroxide, you know already the formula. Then what is zinc hydroxide? Zn OH, zinc valency 2, hydroxide valency is 1. So Zn OH twice. Okay, this is white precipitate. This is a white precipitate. Okay, then plus sodium sulfate. Just now, the previous one we learned sodium sulfate. Sodium valency 1, sulfate 2. Therefore, you get Na2SO4. Na2SO4. So zinc hydroxide is a white precipitate and sodium sulfate will be a solution. Therefore, from the color of the white precipitate, we can come to know zinc is present in the given salt. Sir, calcium also you said white precipitate. Now zinc also you are saying it is a white precipitate. Am I right? Then how do I know whether it is calcium or zinc? There's a question arise, no? Do you understand my question? So, sir, you said calcium also forms calcium hydroxide and the color is white. Zinc forms zinc hydroxide, its color is also white. Then how I can find out whether it is calcium or zinc? Can anyone guess? We should do one more test to distinguish whether it is calcium or zinc. Now we have shortlisted, it could be either calcium or zinc. Now we have to perform one more test to identify whether the given salt is calcium salt or zinc salt. So here you add extra sodium hydroxide. You go on adding sodium hydroxide. What will happen to the zinc hydroxide white precipitate? So initially the white precipitate will form. If we add excess sodium hydroxide, the precipitate will dissolve. The white precipitate will dissolve and become a solution. If it is calcium hydroxide, it won't dissolve in excess sodium hydroxide. The white precipitate remains a solid. And from that we can distinguish whether it is calcium or zinc. Is it clear now?
Yes, sir.
If you go on adding excess sodium hydroxide, calcium hydroxide white precipitate will remain a solid white precipitate. Whereas the white solid precipitate of zinc hydroxide dissolves and turn into a clear solution when we add excess sodium hydroxide solution. Clear? Clear or not?
Yes, sir.
Yeah,
Yes, sir.
when calcium and zinc comes, we need to perform one additional test. We have to add excess sodium hydroxide and see. See, this is a question beautifully asked in your board examination. So when you are identifying the positive ions, we are using sodium hydroxide as reagent. Am I right? We are using sodium hydroxide as reagent. Why we need to add sodium hydroxide drop by drop? Why not we can add sodium hydroxide in bulk? This question had been asked in your board examination. Such a beautiful question, and you got the answer already here. So what is the answer for this? Why we need to add sodium hydroxide drop by drop? So if you
If
add
you
it
add
bulk,
sodium hydroxide bulkly, it will get dissolved.
yeah, even though the precipitate forms, immediately that get dissolved. So we cannot find out which precipitate is formed there, whether the precipitate is formed or not, isn't it? Okay, very good. Who answered that?
Pradeep.
Yeah, excellent, Pradeep. Your answer is perfect. I hope all the other children understood that what it is. So if you add in bulk, the white precipitate of zinc hydroxide would have formed initially and immediately that would have dissolved. We might not have noticed it. If we add drop by drop, initially the white precipitate, we can see no, for every drop a white precipitate will form. And for anything extra we are adding, the white precipitate getting dissolved. We can see with our eyes. And then we can say, okay, the ion present in it is zinc. If we add in bulk in one stretch, we may not be able to notice the precipitate form. Such a beautiful question, and you should be able to answer such questions. Understand? Okay. Shall we move on to the next one?
Yes, sir.
Okay. Lead nitrate plus sodium hydroxide. Okay. Who will answer this? Anybody volunteer to answer this? Maybe anybody. I don't mind.
Lead hydroxide and sodium nitrate.
Lead hydroxide and sodium nitrate. So why? How you got this product? Okay, lead hydroxide and sodium nitrate. That's perfect. But how? Why? Why not be some other product? That is what
So the double displacement
yeah, very good.
reaction.
Why double displacement? Why not single displacement?
Because in the first part of the
No, both are compounds. You say lead nitrate is a compound. Sodium hydroxide is also a compound. Right? When two compounds react, double displacement reaction will happen. Such a straightforward, simple answer. Right? Lead nitrate
Yes,
is a
sir.
compound. Sodium hydroxide is also a compound. This is what I have been telling. But none of you are answering this exact wordings the teachers expect. The examiner will expect. Both are compounds, you should say. Without telling both are compounds, you write anything, they cannot accept it. And both reactants are compounds that will undergo double displacement reaction. So here lead nitrate. So lead is positive and nitrate is negative. Therefore, it's a compound. Sodium positive, hydroxide is negative. Therefore, it is also a compound. Therefore, it undergoes double displacement. So, therefore, you are expecting the product lead hydroxide plus sodium nitrate. Plus sodium nitrate. Okay, now, can you tell me the formula? Okay, Kirtat, can you open your mouth and answer me? Lead nitrate, what is the formula? How will you derive?
PbNO3 twice.
Pb NO3 twice. Okay, good. And sodium hydroxide?
NaOH.
Okay, then lead hydroxide. Don't look at your textbook. You see, you try to give wrong answer, but learn to think.
PbOH twice.
PbOH twice. Good, because lead valency is 2, hydroxide valency is 1. So what is the color of lead hydroxide? This is also white. This is also white. So we need to perform one more test here. Plus what you get? Sodium nitrate. What's the formula of sodium nitrate?
NaNO3.
NaNO3. So this is the only one will be a precipitate. All the other things are solutions. They are all solutions. So only lead hydroxide will form a precipitate. So this is also soluble in excess. This is also soluble in excess sodium hydroxide. So zinc also is soluble in excess sodium hydroxide. Lead is also soluble in excess sodium hydroxide. Then how we can find out whether it is lead or zinc? We need to perform one more test. So that is not necessary for us. That is not in our syllabus now. So how will you distinguish between lead and zinc? But we need to perform one more test to distinguish whether it is lead or zinc. Understand? By this simple test, we cannot say whether it is lead or zinc because both are answering in a similar way. But we can shortlist. It could be either zinc or lead only. Is it clear? Hope it's clear to you.
Yes, sir.
Okay, good.
Yes, sir.
Okay, here ammonium salts are colorless. Ammonium. So here also you'll get, for example, you take ammonium chloride plus sodium hydroxide. Again, compound plus compound, double displacement. You take any salt, maybe ammonium sulfate or ammonium chloride or ammonium nitrate, can be anything that reacts with sodium hydroxide. You get ammonium hydroxide. You get ammonium hydroxide plus sodium chloride. So I have already told you ammonium hydroxide is a weak base. Therefore, that's split into what? Ammonia gas and water. So here no color will form because ammonia gas, this will be evaporated as gas and water is a liquid, colorless liquid. Therefore, no color you will get for ammonium chloride. No precipitate in the very first place. You will not get any precipitate at all. No precipitate. No precipitate. If you add any ammonium salts to sodium hydroxide. Instead, what gas will be liberated? Ammonia gas will be liberated. Here ammonia gas will be liberated. Okay, so these are the things I like to teach you today. And okay, I think we can quickly revise. We can quickly revise all the things, all the 6 things we have seen. Alkali plus salt solution. No? So alkali means what? Sodium hydroxide or it may be potassium hydroxide. So these are the 2 things we can add to any salt solution. If it is calcium nitrate, what is the color of the precipitate you get? What precipitate you will get? You will get calcium hydroxide precipitate, which is white in color, that is insoluble in excess. Am I right? It is insoluble in excess sodium hydroxide. So what is the next one? If you add sodium hydroxide to ferrous sulfate, what color you get? You will get a pale green precipitate of ferrous hydroxide. And if you add sodium hydroxide to ferric chloride, what will you get? If you add ferric chloride, what color you will get? Just now we learned, no? Ferric, what color you will get?
Reddish brown.
Reddish brown.
Reddish brown. What is that compound? Ferric hydroxide, am I right? Ferric hydroxide is reddish brown. Ferrous hydroxide is green. Okay, next one. Copper sulfate. If you add sodium hydroxide or potassium hydroxide to copper sulfate, so what is the precipitate you will get? You will get copper 2 hydroxide. So what is the color of copper 2 hydroxide?
Pale blue.
Blue. Okay, pale blue or blue. Okay. Then zinc sulfate. If you add sodium hydroxide to zinc sulfate, what color? What is the precipitate you will get? You will get zinc hydroxide. Am I right? You will get zinc hydroxide. What is this color? White. But this is soluble in excess. Am I right? This is soluble in excess. Okay. Then what is the next one? Lead nitrate. And what is the precipitate you will get? You will get lead hydroxide precipitate. You will get lead hydroxide precipitate. So what is the color of lead hydroxide? Is also white. This is also soluble in excess. When you add excess sodium hydroxide, both the things will be soluble. So zinc and lead. That is why we need to add sodium hydroxide reagent drop by drop. It should not be added in bulk. So you write that question, put very important, very often asked in the board examination. Okay, why alkali should be added drop by drop? Clear?
Yes, sir.
Okay. So in the next class, for the same 6 salts, instead of sodium hydroxide, we can use ammonium hydroxide. We can use ammonium hydroxide. Same double displacement reaction will happen. Understand? Same double displacement reaction will take place. Same color will form. Instead of sodium, that is ammonium. That is the only difference. All the rest of the procedures are same. But these are the two reagents we need to learn in 10th standard syllabus. If you use sodium hydroxide, what are the different colors you are getting and what are the ions you are able to identify. So instead of sodium hydroxide, we can use ammonium hydroxide also. Okay, so if you go through your textbook, you can easily understand now, instead of sodium hydroxide, how this ammonium hydroxide reacts. And when you add excess, what happens to that precipitate? That also we can easily learn. Okay, any question? Okay, I'll explain you what is single displacement reaction now. One of you asked me that. But before that, any question, any difficulty in understanding this chapter so far?
No, sir.
No, sir.
Okay, so
No,
then,
sir.
okay, so in the next class, we'll be seeing ammonium hydroxide, how ammonium hydroxide will react with salt solution and how the different colors are formed. You should be able to tell me the answer, everything, understand? You know the logic behind it, how to think, how to derive the answer. You know the color now, memorize the color and remember it, and you should be able to tell me when I ask you next time, day after tomorrow. Okay, so now, who asked me single displacement reaction?
Hita.
Okay, so now if you are adding zinc to copper sulfate solution, zinc to copper 2 sulfate. See here, zinc is an element. Zinc is an element, whereas copper sulfate is a compound because this is having both positive and negative. So here zinc is alone, therefore it should be an element. So when an element reacts with a compound, this will undergo single displacement reaction. What does that mean? So split the compound into positive and negative ion. If the element is positive, that will displace the positive ion from the compound. Therefore, this copper will be displaced. That will come out separately as copper. And zinc take the place of the copper. So zinc take the place of the copper and combines with sulfate. Apply the 4 steps rule now, symbols and valencies. Zinc valency 2, sulfate valency is also 2, 1:1. Therefore, you get zinc sulfate, ZnSO. You got it?
Yes, sir.
Okay, it is as simple as this. When both are compounds, double displacement. When one is
So in
element,
this chapter,
Hmm.
it's all about double displacement equations.
yeah, only double displacement reaction in this chapter. All in the entire chapter, all the equations are double displacement reactions.
Okay, sir.
Okay, chemical analysis is completely based on what? Double displacement only. Okay, so let me take one equation and explain you how we can balance it. Okay, quickly I will explain you that ABCD method. Okay, we take this equation. Let me erase what all the things I have written. Sorry. So that is what, see, you can, in 10 seconds, you can balance, write the equation and balance the equation. To that level, you need to practice and master it. So if you plan to take science group or computer science group next year in 11th and 12th, so just try to master all these things. So here what we get, ferric chloride is FeCl3, and what is sodium hydroxide, NaOH. And okay, what are the products we get? Ferric hydroxide, FeOH,
Ferric hydroxide.
and then sodium chloride, NaCl. Now we need to balance. We need to balance. See, I'm not going to tell you the trial and error method that takes longer. Since all of them are double displacement reaction, simply we can apply ABCD algebraic method. We can apply ABCD algebraic method. I'm just changing the color here. So let us put A ferric chloride here. Put some number here. A, B, C, and D. Okay. Now just use mathematics. Now you know how to solve linear equations. You come to 10th standard. I think you would have learned it in mathematics. How to solve X and Y. No, those kind of problems you will be knowing it. Okay, it is very easy now. Now you take the first ion. What is the first ion? First ion is iron. How many ion is there? One FeCl3. So here FeCl3 means what? Fe1Cl3. So one ion, here it is A. Therefore, 1A is equal to, same thing, you take ion in the product side, and how many ions are there? One ion, and in front it is C. So 1A is equal to 1C. Am I right? Is this point clear to you? We put A, B, C, D, E, how many reactants and products are there? You just put A, B, C, D in front of the formula of the compounds, the reactant side and product side. Now you take one by one. Take the ion first. How many ion is there? One ion. And multiply by this number, 1A. Left hand side is 1A. The same ion you take, Fe. How many ions are on the right hand side? Only one. And what is the number in front? C. Therefore, 1 into C is 1C. So 1A is equal to 1C. That means what? A is equal to C. In the balanced equation, A and C will be the same number. Okay, now we take chlorine here. We take chlorine. So the next ion is chlorine. How many chlorine ions on the left hand side? 3 chlorines. Am I right? There are 3 chlorines. And what is the number in front? A. Therefore, 3 into A is 3A. So 3A chlorine in the left hand side is equal to where chlorine is in the product side. So chlorine is here. Am I right? Yes or no? Can anyone say yes or no?
Yes, sir.
Okay, how many?
Yes, sir.
Chlorine? Only one chlorine here, am I right? Only one chlorine. And what is the number in
Yes.
front? D. Therefore, 3A is equal to 1D. Am I right? That means what? D is equal to 3A. D is equal to 3A. Whatever be the number you take A, 3 times of A will be the D. That's what we need to understand. Okay, now let us move on to sodium. So first we need to get that equation. A is equal to C, D is equal to 3A. This is the second equation. Now let us take sodium ion. So simple by this method. Take sodium ion. And how many sodium in sodium hydroxide? Only one here. And what is the number in front? B. Therefore, 1B on the left hand side is equal to what? How many sodiums here on the product side? Only one sodium, no? Na1. Therefore, 1. And what is the number in front? D. Therefore, 1B is equal to 1D. That means what? B is equal to D. So that is the third equation. And what is the fourth ion? Hydroxide. You can take hydroxide together. In double displacement reaction, we need not take every atom separately. You can take hydroxide together. In all double displacement reaction, we can take the whole ion OH together. Okay. How many OH in the left hand side? Only one. And what is the number in front? B. Therefore, 1B on the left hand side is equal to how many hydroxide on the product side? OH 3, no? So 3 hydroxides on the product side. And what is the number in front? C. Therefore, 1B is equal to 3C. Therefore, B is equal to 3C. That is what is fourth equation. Okay, now we have found out the relationship between all these A, B, C, D. Am I right? So let us consider A is equal to 1. Let us consider A is equal to 1. So when A is equal to 1, substituting in equation 1, C also will be 1. Am I right? You got it or not?
Yes, sir.
Yes, sir.
Okay, I'm just changing the color to make it clear to you. Suppose let us take A is equal to 1. If you take A is equal to 1, C also will be 1. Am I right? Because A is equal to C, no, in equation 1. If you take A is 1, C also will be 1. Okay. When you have taken A as 1, D will be equal to 3 into 1. Therefore, D will be equal to 3. Okay. Here in the third equation, B is equal to D. Already we have got D is equal to 3. Therefore, B also will be 3. B also will be 3. Okay, when D is 3, okay, already we have got C as 1, no? We have got C as 1 and B also 3. Right here, B is 3 and C is 1. You substitute this equation also answers the same thing. 3 is equal to 3 into 1. Therefore, here A will be 1. Here A will be 1 and B will be 3. Am I right? B will be 3.
Sir,
Yes.
sir, how will B be 3, sir?
B is equal to D, no? B is equal to D.
So it should be 1, no, sir?
Oh, B is equal to 3, you have got it, no? So B is equal to D. B is equal to D, no? So how much you have got D? D is equal to 3A, isn't it?
Yes, sir.
D is equal to 3. What you assume that A as? A you assume as 1, no?
Yes, sir.
So when you assume A as 1, you got C is 1. Okay. If you come to the second equation, already you assumed A as 1. Therefore, D will be equal to 3 into 1 is equal to 3. Got it?
Yes, sir.
Then the third equation, B is equal to D. Already you got D is 3, no? Therefore, B will be
Yes,
equal to D. And from this, you can easily substitute here. Then C is also, C is 1 and D is 3. And D is, very easily you can balance it. Okay. See, I have recorded this. I upload this in YouTube. And you can go through the entire lesson, know what we have seen for this last 1 hour. Whatever we have seen, no, you can recheck. And you can move forward and backward. You can recheck. And wherever you have not understood, and you can go through it again so that you can learn it thoroughly. Okay, clear?
Yes, sir.
So maybe
Yes,
when
sir.
you see the
Yes,
first
sir.
time this equation,
Yes, sir.
take each and every
Yes, sir.
equation and try to solve it yourself. Hope it's time up already, and I have taken 10 minutes, extra 10-15 minutes. I'm sorry for it. I think next time onwards, so we have to start on time and finish on time, because you will be having another class also, no, immediately after this. So I don't
Yes.
want to take away that time. Okay, thank you very much, children. So you learn everything thoroughly, and if you have any difficulty after I post this in YouTube, you ask your question in the YouTube comments itself. Okay, so that all the other children also can see, and we can learn from each other by the time. Okay, bye.
Yes, sir.
So thank you very much.
Yes, sir. Thank
Thank
you,
you,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Okay, bye bye.
Thank you, sir.